The radiative transport theory describes the wave propagation through a medium characterized by a random distribution of scatters. It usually applies to the electromagnetic radiation but can be generalized to acoustic radiation. The radiative transfer theory is one of two theories that's developed to deal with the radiation absorption and multiple scattering problems. The radiative transfer theory constitutes the physical basis of several remote sensing techniques due to the relative simplicity and capabilities to deal with the multiple scattering effects. In tissues, light transport is crucial in understanding many diseases. It's used clinically as both a therapeutic and diagnostic tool. A concern in these cases is the difficulty of knowing which region of the tissues are sufficiently illuminated for therapeutic results, or from which regions the collected fluorescence was emitted. Development of optical models that explains the observed scattering properties of soft biological tissues is of considerable interest. Light in tissues, the transport equation. Here we have the transporting equation and what each part means. At 1, we can see it's a change in radiance at r in direction s. 2 is a result in loss either due to scattering or absorption. 3 is the source of power generated at r in a direction s. And 4 is the gain due to scattering from all other direction s prime into s, meaning scattering affects the medium from other sources. The participating media. This media may absorb, emit, or scatter light. The simplest participating media can only absorb light. That means that the light passing through the media is attenuated depending on the density of the medium. Participating media can be classified into the properties of tissues and light, where the tissues can adjust the participating media by its refractive index or its absorbing or scattering medium, and light affects it via its absorption capabilities, scattering, reflection, and transmission. Absorption of light takes place when matter captures electromagnetic radiation, converting the energy of photons into internal energy. Energy is transferred from the radiation to the absorbing species. As we can see, sun is directed to the cube and it absorbs all the light. Scattering of light is a phenomenon in which light rays get deviated from a straight path of striking an obstacle like a cube. Scattering the light waves gives rise to many spectacular phenomena. As we can see, the sunlight is directed to the cube and it is scattered in different directions. Fluorescence is the emission of light or other radiation from atoms, molecules that are bombarded by the particles such as electrons, or by radiation from a separate source. The bombarding radiation produces excited atoms, molecules, ions that emit photons as they fall back to ground state. As you can see here, the electrons are bombarding the cube and light is emitted. The assumptions of the transport equation, and these are that the radiation is monochromatic, a radiating beam is parallel, each species absorbs radiation differently, and only non-scattered and not absorbed are detected. Incident radiation and concentration of chromophobes are not extremely high.